had the whole world at our feet, watching seasons change. Our roads were lined with adventure, mountains in the way couldn't keep us from the sea. Here we stand, open arms. This is home where we are, ever strong in the world that we made. I still hear you in the breeze, see your shadow
good evening everyone, and I hope you enjoyed the music, since I did. That's why we started a couple of seconds later. So, good evening and welcome to another of my live streams. Today we will be talking about picoCTF again. Like, this is the 6th part of the picoCTF series. I hope to solve all the challenges which were published on picoCTF 2019. And there seems to be like 100 of them in total, I think. So yeah, so there you have it. Like, welcome to the 6th part, and that's probably not the last part either. So yeah, we'll be hacking again. Hope to get a couple of more flags, but this is going slower and slower, basically due to the fact that, well, the challenges are getting harder and harder. So if on the first part we were able to solve like 30 challenges or whatever, right? Then on the last part we solved like 5, I think, maybe in total. So yeah, it will be getting slower and slower. Anyway, today's moderator is Disconnected. Disconnected, as you can see, his nickname here, is going to help me with moderation. What that basically means is that if you have any questions for me, you actually need to write @disconnected on YouTube chat or Discord, and to pass the question on to him so he can pass it back to me, because I'm not always looking at the chat. I try to, but I'm usually focused on the tasks or whatever. And however, we do keep a list of questions which I can see on my other screen. So when I have a slower moment, like a pause between tasks or something like that, I can look at the questions and answer them then. So again, if you have any questions about the topic, about something else, then do ping Disconnected. If you are on our IRC, then you can just write !Q and then the question, and that will pop up in my list of questions as well. So there you have it. Perfect. What we will be doing now, we will be switching to desktop, and I will be going through some random news for a couple of minutes so that, people basically who are late but still want to see it live will come in, will have some time to be late, and then we will get started with hacking. So let's start with, let's start with actually running the with running my, Microsoft's application so I can do zooming on screen. Here we go. Perfect. This is Disconnected's Twitter account. Follow him. He tweets super interesting stuff. For example, he tweets about PageOut, since he is also involved in the project. And yeah, we are still looking for PageOut offers. I will talk about it in a second. I guess I will give you the link to Disconnected's Twitter on our chats here and there, so you can take a look and follow him. He's also, by the way, the captain of Just Cut the Fish, which is one of the Polish CTF teams. We have quite a lot of Polish CTF teams nowadays. If I'm not mistaken, there were top 25 in the world last season, so that's a pretty good team as well. Perfect. Now let's go to PageOut. Yes, PageOut, as you know, this is the magazine or zine which I thought might be a good idea, and some people thought it might be a good idea, so we actually made it. And if you go to pageout.institute, you can download 2 issues of the magazine, of the zine, that would be, or of mag, whatever you want to call it. Issue 2 and Issue 1. Issue 1 was published in August last year, Issue 2 was published in November last year, and we are on the way to basically publishing the 3rd one. The 3rd one will be published, will have like this cover, and it will be published around middle of March, unless we don't get enough articles. So if you want to write an article, the deadline for submitting an article is around February 20. That's, by the way, like a most probable deadline. We might move it a little bit further depending on how everything goes. Do not trust this counter, by the way. This counter doesn't show anything, but we already got some submissions. It's just that we are retooling some things, and the counter doesn't work right now, basically. But we already got, I think, like around 10 articles, I think, so we are already somewhere here. Yeah, so there you have it. You can also download, for example, this cool wallpaper, and yeah. Then, yeah, what Yeah, what the Twitter community is, like InfoSec community is talking about today is basically the Windows bug with certificates, where basically it turned out that I think the ECC, like elliptic curve, certificates were kinda broken and signatures were kinda broken in Windows for some time now, and like the gossips go basically that NSA discovered it and they kept it in the drawer like probably using for some time, and then when they basically learned that some other parties discovered it as well, then they reported it to Microsoft and Microsoft fixed it. These are the gossips, right, which I heard. I'm not sure how true that is. Anyway, so yeah, I guess we live in interesting times. If you are using Windows, make sure to upgrade. Make sure to, get patches from yesterday's Patch Tuesday and install them. Otherwise, SSL might not be working as expected. That being said, if you are on Windows 7 is dead, so you will not be able to update. I did see already some companies advertising themselves that they will be providing patches for Windows 7 for a certain price, of course. I'm wondering, like that sounds like an interesting business model, so I'm wondering how will that work out. Then, then we have Pico. So before we get to Pico, let's just like talk for 4 more minutes before we get to flags, and then we get to flags. What do I have to talk about? I don't know. Oh, for example, after coming back after holidays, I found quite a lot of stuff in my mailbox. For example, I found this, which is, I'm not sure if you can actually read it. Yeah, it's a LAN to RS232, basically, a COM connection to Ethernet connection. Device, let's call it an adapter. It's probably an actual like computer inside which does the conversion. I don't think it's I actually didn't take it apart. I need to take it apart later on. But it's quite interesting. I found it by accident on like the local supplier for like local Amazon, Digitech basically. And if this actually works as advertised, I have an RS232 original adapter for Atari 800 XL, which I have. So maybe I can just use this to connect my Atari to the internet. I'm quite curious to play with it, so we'll see. Another funny thing which I saw, I basically like just went, like there is this company which makes these, which it's called DE-Lock, and it's like I think semi-small company which does weird devices, a lot of weird devices. They are, I think, German. And another thing so I went on a shopping spree, like just looking for what this company makes, because they make really interesting things. Another thing which I found was, I think they're just like rebranding some of the stuff, but whatever, was this. This is, come on, focus. Yeah, sorry, like focusing the camera is rather hard. I tried to learn this trick on YouTube for like actually covering it, but it doesn't work too well. And all in all, it's basically like a jack plug, which you plug into the headphones jack in your phone. And at the end, right, like here, it has a button. So you plug it in and then you download an app, and every time you click the button, it works and it does whatever you program the application to do. So it's supposed to work like the same as your headphones might have some buttons, to do volume up, volume down, and then next track, previous track, stop, play, and so on. So this is like quite interesting. I'm also quite curious to see if this works and how it works, because I actually have no idea. I have some predictions on how the protocol for these buttons might work on audio channel, but I never tested it, so that's something I also want to find out. Yeah, like interesting stuff. Anyway, so yeah, but basically ate 3 minutes, and for the last minute we have a question. Perfect. From Clowfish, I guess you say it. I'm not sure how you pronounce your name. I am terrible with names, and I always butcher people's names. I apologize for that. Did anyone try to brute force CTF flags in general? Is it prohibited? So in general, it's prohibited. As in, there are even some CTFs that only like after they detect your brute forcing, they will just like say, okay, you are blocked now, congratulations. So I wouldn't do it. Now, that being said, not many, but some CTFs actually do a client-side verification before they send the flag to the server side. And this is done using like SHA-256 hash. So they hash your flag in JavaScript, they check it against like the hard-coded value in JavaScript, and then they send it to the server. Now, this means you can actually brute force the flag because you have the hash of the flag, right? Which, well, the flags are obviously not brute forceable, but perhaps if you have a task where you get, like, if you reverse engineer most of a challenge, you can get 1 million probable flags, and then instead of reverse engineering further to, you know, to like decrease the scope to 1 flag, you just generate the million flags and you check if any of them matches the hash. And this is fair game in such CTFs because, well, I don't think rules would forbid it because this is not enforceable. Like, you cannot detect if somebody is brute forcing offline due to a hash you put in the front end. So that's that. Apart from that, there's also like a typical question: where does brute forcing start? For example, if you do 10 tries of a flag, is it brute forcing? If you do like 1 million tries, is it this brute forcing? Well, probably yes, right? 10 flags, maybe no. I would say the limit is like the line is around 10 flags. If I am like guessing the end of a flag for some reason, I would usually like go for around like 5 to 10 guesses, and then I would stop because I would, well, probably say that this is actually brute forcing, so I shouldn't. And you probably saw me on last live stream doing it. I didn't explain it, but yeah, I did try several flags, but after a couple I did stop and solve the task till the end, right? So yeah, in general, I would assume it's prohibited. Do not brute force on the server. This will get you banned. Tracking 10 flags is usually fine. If for some reason the CTF has a hash of a flag in the front end, then this is fair game. But it is fair game, but it usually will not give you a lot. Okay, that Ethernet to serial is exposed internet, mainly ICS. I do not fully understand your comment. I'm sorry. Yeah, sorry, I do not understand the comment. If you could rephrase it and like comment again. And the last one, can you program this head-jack device to do more than just volume? Like this thing. Probably no. I think it's actually like when you press it, like you get an Android key press event or something like that, and then like whatever registers as a global handler for that key can do whatever it is allowed to do. So I don't think you can do, it's like not a keyboard. It's much simpler. It's just like probably get like an event button 1 or whatever, and that's it, and there's nothing by default programmed on it. So yeah, I would definitely not expect anything like a full keyboard protocol on audio devices. Oh, okay. So the comment was that the Ethernet to serial adapter is used to expose ICS system to the internet. Okay, now I understand. I'm sorry. ICS, what's ICS? ICS system. Let me see. Is it SCADA? Incident command system. I don't think that's it. Internal control system. Maybe that's it. Which ICS are we talking about? I'm thinking it's about industrial control system. Yeah, SCADA. This is what I meant. Okay, yeah. I think that's actually it. Since the device itself has like some place for screws, this is also like a typical power connector which you find in SCADA. So, well, connector, right? You just like put in wires there and screw them in. So I believe you're absolutely right. This is probably an industrial device. Also, please do not expose SCADA devices to the internet. This probably is a bad idea. Okay. Cool. So, let's get started with Pico. And to do that, I need to switch to desktop. And yeah. We have already this amount of points, 10,350, and that means we have 61 solved, 23 unsolved. We are solving like tasks through several parts, and this number of unsolved doesn't change because each time we solve something, something else is being unlocked. So let's look only at the solved ones, not solved, no, unsolved ones. I am going still today to skip through Moonwalk. This is again the slow scan TV thingy. I will go back to it when I finally download some applications that could properly handle it on my sound card setup. So I'm going to skip anything which is sound related today. I mean, there will be other streams anyway, so we will get back to that later on. And I will skip that task and I will go to the next task, which is, or maybe a prior task. We are skipping this one as well. Leapfrog, what are we? Binary exploitation. Yeah, let's start with binary exploitation, because why not? 300 points, so like stuff is getting serious. Can you jump your way to win in the following program and get the flag? Can you find the program? You can find the program somewhere here, or you can use the source. So cool, let's download it. Let's download the source, and I do need to connect to the actual SSH of CTF. So please give me a moment. I will do that. Shell. Okay. Okay, I'm trying to find like the last SSH I used, but I've done so much SSHing to computers which I have here doing weird stuff. If you're wondering what does weird stuff mean in this case, weird stuff means I'm doing TCP over VGA, I probably mentioned already, and yeah, it's like a huge mess of cables currently, which kinda works, but I still need to... When it starts really working, I will do a live stream about it. Let's do it like this. Okay. So, yes, I did find the proper connection. Oops. I did find the password. Okay, and I'm connected. I'm sorry, let's go back to the desktop. I just wanted to make sure I do not disclose my password. I think I did not disclose it. Unless you could see it in my, reflection of my glasses or something, then, yeah, game over. Whatever. Yeah, leapfrog. So, leapfrog. Okay. Let's go to this directory, and then we will... sorry. Okay, and we have a C source code, which I downloaded, binary, which is again working with privileges of a different group. You can see it here with this S, right? SJIT, like set group ID of this group. And then we have a flag file, which is readable only by the owner and only by, which is like we're not the owner, right? And it's only readable by the group, like this group, so we cannot read it, but if we exploit the application, it will be able to read it. Standard wargaming setup, nothing magical here. Let me open the source code for you. So here we are with the source code. Let me, what else do we need to do? We could actually also check what are the protections on like mitigations compiled into that binary. So checksec, this is checksec.sh. You can find it, like Google it. It's a really cool script to do the checking. And let's, yeah, as usual. Oh, so we have, we don't have a canary, we do have NX enabled, meaning stack is writable but not executable, so the heap isn't also like executable. No ASLR, so we do not have to worry about guessing where in memory the binary is located. The binary will be located at a predictable address. No stack canary, which means we do not care about canaries either, so well, that's fine. That makes it simple. Now let's look at the actual application, the source code. Do I plan to finish picoCTF? Yes, probably yes. I would like to do all the tasks. We might do some other live streams in between, but like this one and the next one probably will be picoCTF, maybe even the next one, and then we might do a different topic and then go back to picoCTF because I really want to do each and every task of picoCTF. Okay, so I'm not going to talk about this one, we talked about it previously already. This is the same, so we just jump to vuln, which is the actual application. It does, like, it has a 16-byte buffer, it prints something, it doesn't flash it, it doesn't need to flash it due to this line, and then it gets from standard input into the buffer. This is a buffer overflow, does not care about any boundaries, it doesn't know about any boundaries, and reads the standard input until a new line is discovered. It doesn't care about binary zeros, binary data, everything goes well into gets until a new line is found, and then new lines are not, I think it's not included at the end. Which is a good thing, because even if like we have some data and at the end we send a new line, right, the actual gets will put at the end a string terminator instead, which can be important in some cases. So that's it. This is the whole application which we are going to exploit, apart from the fact that in the binary there are other functions. So let's look at the other functions. We have a displayFlag function, and then we have a leaps function. So we have 3 global flags, right? We have this win1, win2, and win3. Then we have leap A, which actually sets the win flag to true. Then we have leap 2, which sets it checks an argument if it's that beef, this argument, and if so, it sets it to true. Otherwise, it prints some debug messages, which is quite nice. And then leap 3 checks if win, and like this is always false, right? So this is never going to be set if we jump to the beginning of a function. What we need to do probably here is just jump to the middle of a function. Now, the proper way to solve it, oh by the way, and after we do that, we have to jump here to this function which reads the flag, then it checks if all the global flags are true, to evaluate to true. And then if it says like if win1 or win3, nice try, you're getting there, but yeah, I'm not really sure like what is the purpose of this, but the real purpose is actually to get like win1, win2, and win3, and then to set all these flags and then to jump here. Now this is the way you should do it. Again, on CTFs, how do you get the flag? As long as you don't break any CTF rules, doesn't matter. You need the flag, you need to get the flag. So as usual, I might try to think about a different way to get the flag easier, because I'm too lazy to actually set the arguments or whatever. It's not so hard to set the arguments, and it's also slightly boring. That being said, let me open the binary in IDA, but I do not know what the architecture of it is yet, so I'm going to do file on it. It's a 32-bit, that's a surprise actually, I expected 64-bit, so okay, let me open 32-bit IDA. IDA, here we go, okay, I was looking at like which monitor was it going to show up. Here we go. So yeah, what we need to do is we need to go into like why is it really named like this in the source code? It's quite funny because it's like leap A, however, there's no leap B, is actually leap 2. Okay, that's fine. So there's the leap A, which does something and sets basically like sets this. And then we have, so, okay, I am absolutely lazy and I do not want to like go here. What do I do? How do I go about it? What I'm going to do is I'm going to put the address of, because the actual goal is to set these and call get like display flag, right? And we can check how how this condition in display flag is actually implemented. Because it might be checking against 1, but it's probably not checking against 1, it's probably checking if something is non-zero. I want to confirm that, and if it's so, then we are going to, So yeah, it tests if something is 0, then go somewhere, and otherwise display flag. So yeah, it checks does a check if a given flag is non-zero. It does not check if it's true, like true as in 1, 1 is usually equal to true, sorry, true is usually defined as 1 as a number, right? But it doesn't check if it's 1, it checks if it's non-zero, which is great for us because it can be anything in that case. So what we are going to do is we are going to absolutely ignore these leap functions, which normally you would call to the 1, the 2, and the 3, and instead we are going to call gets, like this gets, on the with the buffer address, with this address provided as an input, we are going to put like ABC there, because it's just what, like 3 bytes, right? So ABC. A goes here, B goes here, and C goes here, and then we are going to call the display flag function, and it's done. Because like we do not need to do anything else. So we need a gets address. Where is a gets address? We should have one in main. I do need a notepad to note this down though. So note. And here's my notepad. Now we need address of gets. So we go to vuln and here's gets. So we call gets and this is the address of gets. So this is gets, right? Then we have, we need the address of the buffers. Sorry, of the global flags, obviously. So we go here, this is the address. This is like 1, 2, 3. And then we need the display flag, yeah, this function address. Can I illustrate the technique? Yeah, let's do it in a second. Let me just note the addresses and I will show you basically what are we going to go for and what do we want to achieve. I'm also going to check this function. How does it actually, how the stack in this function works? It allocates 14. So, I wonder what does this do? Does it, I hope this doesn't do anything weird. Well, whatever. We will kind of do like some tries basically of it. Okay, so basically the idea is that there is this buffer on the stack, right? Which is like 16, so let's mark it here. After it there is like something on the stack, I don't know what, doesn't matter, like just a few bytes of it, and then there is the return address, right? So normally what you would do is you would override this return address with the leap a function, and then probably like leap 2, and then like with some arguments, and like leap 3 with some other arguments. However, what we are going to do instead, we are going to override this one with gets address. And the next item here will be the address of a win buffer. So this will be the like win1 address basically. So that would be address of, oh, I cannot, that's weird, I cannot do an ampersand. So, well, you have to believe me, this is the address of win1. And therefore, the CPU gets to the end of a function, reads the return address, and jumps to the beginning of gets. Now, oh, actually, here we will, no, this is here, we need another argument, but I will get to it in a second. And then gets executed and reads the win1 argument like as the address, and it starts writing whatever we type in standard input. It starts outputting it to memory at the address of win1. So the flags in memory like win1, win2, and win3 suddenly gets like overwritten by whatever gets is writing there, which is non-zero, which means it's true. And then here, actually, this is like the next return address, right? Like after gets to the end, it will look for its own return address, and the return address will be here, and it will be like the display function. So here we basically get the display flag, right? So gets, as it is done overwriting this stuff, it gets to its own return, or like reads the address of this from the stack. So it reads this address, which is here. And this address is the address of the function display flags. So the CPU jumps to the beginning of display flags, loads the flags, and then happily displays as the flags, because all of these global variables have been overwritten with true values, so all the conditions match, and that's it. So yeah, like we should be able to do it with 3 words basically. And okay, so let's just encode it. Again, little endian. So like that would be 30, 84, 04, 08, that's gets. Then after the gets, we need the return address of this thing, so that's going to be B3, 86, 04, 08, just bytes from the end. And then the argument of gets is like the order is weird because we aren't really calling a function, but the called function expects that the first thing on the stack is the return address it's supposed to use. That's why we will have that when we call gets, what the next thing is not the argument, but it's actually the return address of gets, like where gets is supposed to return to, which will be the display flag. Yeah, so this is the last one, which is 3D, 04, 08. And yeah, that's basically it. Now I just need to somehow encode it in binary, which I'm going to use bash again to do it. So I'm adding this escapes. And then at the end, I need a new line sign to commit it, right, to push it. And then it gets executed, and then suddenly this gets, which we are calling, it starts to get executed. So we need to push like ABC there, and then like just a new line to finish things off. Now, as I mentioned, we need at least like 16 A's. Probably we need a couple of more. Let's count how many. So this is the vulnerable function, right? Let's look at the stack. This is where the buffer is actually where we are writing. So we are writing 16 bytes from here to here, which means then that we have 4 bytes of unknown, and then like 4 bytes of this, 4 bytes so 12 more bytes, and then there's R, which is the return address. So 12 more bytes on top of A's. These are 16 A's. Now I need like 12 B's, so like BBB, CCC, DDD. I am not counting this really like, you know, like rigorously. I'm basically trying to if something will not work, I will just like start removing and adding D words until it works. And that's it. So now we need to echo it with E-E-N basically. E is for escaping values like this, so this gets converted to actually binary byte of value 4. N is for omitting the new line, because we have the new line here anyway. By the way, and I probably should do it like this with actually a single quote instead of a double quote, and we want to redirect it this to ROP. Now we can try to run it on my computer, so this is my computer, let's just run it. And it says enter input, flag is missing, which means it at least jumped to the display function, which is fine. Let's actually put something to like the flag asdf in the flag.txt, and let's run it again, and it says like segmentation fault, because I have no idea why. Which is weird, but okay, let's try it on the real machine. Maybe on the real machine it will actually work. It might not, but it might, who knows, so let's just try it. So we are here, let's, I'm copy pasting it, I'm running it, and it did crash again, but I did get the flag. Oh, by the way, I didn't even notice that we got the flag as well. So yeah, that's basically it. That's like, I didn't look at the functions, like at the conditions in the functions, what kind of arguments do I need to pass, what is the logic there. I just like went for the actual condition, which is checked at the end in display flag, and that's how we got this flag. Now, if we would want to do it properly instead, so this is the flag, yeah, this is correct, we got it. If we would want to do it correctly, it wouldn't be much harder. We would basically have to set the first return address to the address of this function. Then it doesn't take any arguments, so just after the return address of this function, we put the next return address, which we would do anyway, and then we should probably jump to, yeah, we need to set win3. We need to set win3. So we are going to jump here, but we are not jumping here actually. Where we need to jump is we need to jump here. So if we look in IDA actually at this function, so that would be leap3, right? This is where the condition is checked. And then this is where the flag is actually set. So it would be best if we would jump to this address. So like the code execution returns here, and it goes here, and then it does like this this move, this leave, and this return. So we kinda need to make sure that EBP is like has a sane value, because if it doesn't have a sane value, then it will crash at this point. But apart from that, it should be fine. So that basically means that we need to put a sane value in the instead of, where is our exploit? Here, instead of this DDD, we would have to put some address which is writable or like readable from memory actually. And after this, we would put another value, which would be the value of the last function, which is like leap2. And we could, for all we care, we could just jump here again and like totally ignore this condition, right? But we could jump at the beginning of a function, that would work as well. So that's basically it, and at the end we again do the same as we did in our code, jump to display flag is kind enough to read the flag for us, like fopen on the flag, get it to memory and print it out, if the conditions are met, right? And the conditions would be met in this case. So this is how you would go about it, like if you want to do it by the book, but again, CTFs, you do not do stuff by the book, you do stuff that gets you the flag, right? And here it was easier for us to just overwrite win flags in the memory and jump straight to display flags, like kind of CTF speedrunning. Are there any questions? Is it possible to just jump to the print part of the display flag, avoiding the win condition checks? Excellent question, Joel. So let me show you the question, by the way. Let's look at the code and let's think about it. Now the code is kinda, the answer would be quite funny. The answer would be maybe. So it's like this. When we enter this function, the first thing this does, right, is it's getting the flag from the file, and then it checks the condition. If the condition is false, we still get to a return. There's no exit, we still get to a return. We might get like some, like this. We might get like this printed, and then we get to return. So, which means if we omit the checks and we jump straight here, then we have a problem, because the flag was not loaded into memory. This never happened. The opening of a file never happened. And we cannot selectively jump over code. Like, this is not possible. We can jump into the middle of a function, but we cannot get it, but it will always execute until the return. Which means if we jump at the beginning, it will execute until return. We cannot selectively jump over code. That's not possible. Now, what I said makes you think probably that is not possible, but there's one funny thing here, and this is this. This is an uninitialized variable, meaning, basically, if we the flag gets loaded into the memory and is being placed on the stack. Even if this condition fails and we get into a return and it's never printed out, right? It's still being loaded into the memory onto the stack. This means it's on the stack. So then, if we would after that actually jump to some function which prints something which is on the stack, for example, you would call this, and then you would jump here, like you would call the display flag function, and then you would call it again, but jumping into the middle, into printing something on the stack. This is basically printing something on the stack. You might get most or all of the flag. So that's actually a good question, Joel, and let's see if this works. Because I mean, again, what the problem here is basically that they should get all this code into the condition, but they couldn't do it because, like, if they would do that, then you could just jump to this code. So this is quite hard. No, actually, what I changed my mind. What they should do, they should here memcopy, like before the return, they should actually like mem set it to 0, like just remove the flag from memory if it failed, if the condition failed. But they don't do it. So let's try if we can actually go about it that way. So we know that at the end. So here. This is the display flag address, right? And now let's grab the address in the display flag at the middle. So at the middle would be not here, it would be here, right? So yeah, what's the value of s? Value of s is, this is fine. I think we can just jump here to this address and it might work. So this is the address. Now we need to encode it like little endian again. Normally on a CTF you'd just use a function for it. I'm doing it manually because I'm too lazy to open Python. Okay. So we jump here and then we jump here and we see if this actually works. And what we need to add is we need to add this. One more check is this EBP? It is EBP, which might actually complicate things a bit. If that would be ESP, it would work, but EBP will be destroyed by us, because when we are leaving the vuln, right, it does a leave, and what leave does, it basically pops a value from the stack, like pops this DDD from the stack, and it puts it in EBP register. So that's not good. That's quite not good. On the other hand, yeah, because then when we go to display flag, it like pushes this old value on the stack, and then it goes to leave and actually grabs this old value from the stack. So this is quite bad for us, because that means we have a clobbered EBP register, and therefore we cannot really, yeah, we cannot really like, we do not know the stack address, and we, like, I did say at the beginning that the binary doesn't have ASLR, but that is true for the binary itself. We know where the binary is located in memory, but we do not know where the stack is located in memory, because the ASLR still applies to the stack. And therefore we cannot really guess where the stack is. We could kinda guess it, but let's assume we cannot guess it. Which makes things complicated, because we cannot really use this. The question is, what could we use instead of that? Could we use some value which is already on the stack? Maybe we could find some pointer on the stack, do some knobs and align with it, but it gets a little bit more complicated, a tad more complicated. So yeah, this will not work due to this being EBP instead of being ESP. I'm not really sure we can do much about it actually, because like all the puts are called on non-stack stuff. So yeah, this wouldn't work. It might work if we would like somehow get the address of the stack back into EBP, and it also would have to be like close enough to where the flag is located on the stack, basically. So yeah, there you have it. The answer is maybe, but it would take a lot more thinking than actually the method which I showed you does. It's still, Joel, it's still a pretty much excellent question. In some cases, it might actually have worked, and it might have been easier than what I did. So yeah, again, excellent question. It kind of relied on the fact that the value, but the array wasn't, like the flag array wasn't initialized. Cool. Can we just jump to magic address in libc and be done with it? Yes, we could. We probably could do that. We could just... the issue is we do not know where the C library is located. So we would have to first leak the address of the C library, because the C library is still influenced by address space layout randomization. So we know where the binary is, but we have no idea where the libc is. The same way we have no idea where the stack is. So yeah, we would first have to figure out where is it located. So we need an infoleak for that, some kind of an infoleak. And we would have to know, well, after that we would have to know the version, but which is quite easy to do, by the way, because we have a shell. And then we could jump into the magic gadget, and a magic gadget, what it does, it basically runs bash. So there's like a couple of addresses in memory in libc where you just jump, it spawns you a shell. Like this is part of the system function, part of popen function, part of like a couple of other functions, like I actually don't remember which other ones, but like popen and system is for sure. So it's good to remember that such things exist. They kinda depend on how libc is compiled, and sometimes you, like in a given version of a library, you might have a magic gadget. In other versions, you might not have a magic gadget. So there you have it. Cool, that is done. So let's look at the next one. Okay, messy malloc. Can you take advantage of misuse malloc codes to leak secret through the service? let's look at something which is not binary for now, and then we'll get to this. I'm kind of afraid of it because it kind of sounds like heap exploitation. I'm not really a huge fan of heap exploitation. So let's look at something else. There's like reverse engineering. Okay, let's do reverse engineering. We have recovered a binary and a text file, can reverse engineer the flag. Let's do this one, reverse cipher. And I need to create a directory for it. Cool, so now we need to download the binary and the text file. And let's take a look. What are we dealing with? By the way, I am going to not close this one, but I am going to close this one. Okay. Yeah. Yeah, you say heap is fun. Yeah, heap is fun, but I fully agree. I just never learned like the standard techniques for heap. I always like, if I get to do something with heap, it's always like basically not using the techniques which real heap exploiters know. Is more about like knowing how in general stuff works and using that knowledge, which means I can usually exploit it, but it's way slower. Okay, we have two files, rev and revvis. Let's look at revvis. And it's a clobbered version of a flag. I don't believe this is actually the flag. So I would assume it's broken. And then we have this rev file, which is a 64-bit x64 executable, 64-bit x64. So I believe we have to reverse engineer it, which means we can open it in IDA, for example. Let's open it in IDA. Okay, I'm going to cheat a little and I'm going to press F5. I guess like you can download Jidra nowadays, you can download the free version of IDA with the compiler, so this isn't really far-fetched anymore. Okay, so we open the flag, we open revvis, and it actually appends to the flag. That's quite interesting. I guess this is to not... Yeah, this is not to remove the file from people's disks if they actually run it. If there is no flag, it says like... yeah, like flag not found. Please run this on the server. Then it reads from the stream from this one. What was that, like 24 bytes decimal? And if it doesn't work, it just exits. Otherwise, it goes through the first 8 bytes and it just copies them. This is just copying them, right? Like it gets the value from the memory, from the I location, and then it outputs it in the stream, which is v7, which is this revvis. So it copies the first 8 bytes. Well, that's picoCTF and then opening bracket, right? And then for the rest of the bytes, which it seems there are only 23 bytes in the end, like this is less than or equal to 22, which means there are 23 bytes. It does like, it checks whether whether the index is it even or is it odd, right? So they check basically the last bit, and if it's even, it adds 5 to it. If it's odd, it decrements it by 2, and then it writes it to the output stream. So basically what we have to do is we have to reverse it. So for every position which is even, we have to decrement it by 5, and for every position which is odd, we have to increment it by 2, and that's about it. So let's do it in Python. asdf.py, and d is equal to byte array, open rev this as a binary file, read binary, and do a read on it. And then for the positions of for I in range of 8 to 23, as I mentioned, we do if I is like if it's even. I've written it, as you can see, like the even odd differently, but that's the same thing. Then d of I, we need to increment it by 5, right? Sorry. Then we need to decrement the 2, or am I? No, it's the other way around. This is decrement, this is increment, and then we can just like print d, and that's it. So we've done this. Now we need to run it, Python, and like that's Python 3 actually, asdf, and yeah, this is the flag, reverse something something, which is fine. So there wasn't much, as you could see, like much to do. Okay, and this is correct, this is done. Like, just reverse the order, like the operations. Not even the order, just the operations. We changed plus to a minus, which is like, you know, minus is a reverse operation of n plus, and the same the opposite way. In like reverse engineering, when you like meet challenges like that, there are only a couple standard operations which are used in such challenges, and that would be add or sub, so increment or decrement, or like add and subtract. Then there is roll and roar, which is rotate bits like one way or the other way. This is not the same as shift, it's actually rotating the bits, so that means that the bits which are falling out on the other side are appended on the side instead of like whatever was there. And XOR. And I think these are like the... You rarely see any other operations, and you like these are, you know, like basically if you see one, you change it to the other, if you see one, you change it to the other, and if you see multiple operations chained together, you basically also need to reverse the order of the operations. Sometimes it's a little bit more complicated, but at the end of the day, it goes like this. Yeah. Why you can think fast like this? Because I saw like a lot of challenges like that, and I've made my share of challenges like that, so I just know there are some patterns in the challenges. Basically, that's basically it. Cool, so we have this done. Now, I do believe there was another question. Oh yeah, what is the difference? Let me maybe show you the question, which should appear at the bottom bar, at the bottom of your screen. What is the difference between appending and reading the file with fopen? Appending, so if you append to, okay, this is actually a really good question. Let's open Notepad this time. So, okay, if you have a file, right, and the file is called like asdf.txt, you can open it in a couple of ways. You can open as append, you can open as read, you can open it as read plus, as write, or as write plus. These are, and like you can also add the binary flag to it, but it doesn't change anything, which I'm going to say now. And let's assume that the file content is like this. Now, if you open it to append, the file, if it exists, if it doesn't exist, it gets created. If it does not exist, it gets created, but it exists in this case. And the cursor of the file, like, you know, the writing head or the reading head, or actually is one head, right? The cursor is basically, the cursor is put at the end of the file. So if you do a read now, well, there is nothing after the cursor, because your cursor is your head, your reading head is at the end of the file. If you'd write something, it would get appended to the end of a file, which is exactly what appends mean, like append to the end of a file. If you'd want to read the data which is already in the file, I'm not sure that's actually possible with append, or if you'd like to overwrite this data, you would have to move the cursor with a seek operation to the beginning of a file, and then you could overwrite the data, otherwise you would append to the end. So it doesn't remove any content which is in the file, it just appends at the end of the file. Yeah. Then we have a read. The read doesn't allow you to write, obviously, to the file, and it sets the cursor, the read head, at the beginning of the file. And whatever content in the file there is, it remains there, obviously, because you're trying to read it. Then you have the read plus, which is reading and writing. And it also sets the cursor at the beginning of a file, but now you can actually both read and write to the file. Then we have a write. If a write finds a file which already exists and has some content, the first thing it does, it truncates the file, which means it deletes all the data and puts the cursor at the beginning. If you have a write plus, I actually don't remember, but I think write plus doesn't actually... Either it doesn't exist at all and I am just totally making stuff up right now, or it actually doesn't remove the content of a file and just sets the cursor at the beginning of a file. But these are basically like the basic open modes which you can see in a lot of languages. There might be some other flags on top of that. When opening a file, sometimes you can get like really... There are functions which allow you to pass a lot of different attributes and arguments. Like, for example, you can say what is at the beginning when the file is created, what are supposed to be the security descriptors of it, like who has access to this file from the beginning, right? what are the access rights to it. Or like, how do you want the operating system to cache the file? Maybe you want it to cache forward. So if you are reading, the operating system tries to get you the data from like, the further places in the file. So when you actually read, you call the read function, the operating system already has it in memory and can just pass it to you. Or maybe you want to tell the operating system like, no need to do that and waste memory and waste the cycles, because you will just be jumping like crazy through all the file, and you'll basically be using it as random access, and the cache would be just useless and just a waste of cycles. So yeah, but usually using fopen, you are just limited to these couple of flags. Okay, so that's that. If we open a file with fopen, if we exit a function without fclose, do we have file handle opened in proc? Yes, we do. Did the file... That's actually a really good question. Let me look at the previous challenge again. You do say that we open it, but we do not close it. Which is true. We open it, but we never close it, so it remains open. Until the exit of a process, it will remain open. This is quite interesting. I don't think you could do anything fun with it this time, but sometimes there are cases where you could do fun stuff with it. With like when, handles get lost, or like there are too many handles. I think Mateusz Jurczyk had a fun bug in Windows like years ago, where he noted that there was like a funny behavior with some reference counters. Like if you'd open a dynamic library too many times, it would, and then close it, like nothing would happen, and the library would remain in memory. But there are some fun things you could do without it, with that, but I don't remember anymore. That was years ago. Oh, showing people where to find this info. This is a really good point. So where you could find this, you could find it in man, obviously, man fopen. And here you have, like, this is just like the second page of it. And here you have everything described. And this is true for almost every language. Like, even if you do the same, like use open or whatever in Python, or like fopen in PHP, they try to keep the flag meaning the same. Okay, so next one. Okay, so we have this. I said I do not want to do that one yet. Oh, use a format string. Yes, format string. I actually really like format strings. Let's do this one. Yeah, format strings is where you know, printf, which is usually your friend, it turns out is your worst enemy. And we are going to be exploiting it seems. So let's download it, let's download the program. I'm guessing this is going to be a 32-bit binary. Let's check what protections are there. I'm guessing the ASLR will be disabled. So check sec file and the vulnerability. Oh wow, actually like everything is enabled. This is amazing. So we have, yeah, we have Pi enabled. We have a canary. Okay, this is going to be fun. And then I want to check also, and it's a 32-bit binary, so it's not so bad. Like 32-bit ASLR isn't so hard. At the end of the day, like you could sometimes brute force it. Okay, so the source code. Here we go. I thought format strings were eradicated, their best survives rights. Yes, everybody thinks so, and then like every year there's like at least one format string back. But yeah, they should usually be considered eradicated, because like even Windows Vista had already some mitigations against it. I know that if you compile the source code with fortified argument, it also, you cannot basically exploit it. So it's kind of dead, but it's kind of shows up from time to time anyway. Okay, main, input whatever string you want, then it will be printed back. Now the catch here is that it will be printed back with, okay, how will it be printed back? I don't know, let's see. The flag is by the way loaded into memory Where is it loaded? It's loaded into a buffer. Where is the buffer? The buffer is in the global memory? No, where is the buffer? Seriously. Oh, it's malloc is in the heap memory. Which is quite funny, because the heap memory is actually, it might, depending on the configuration of the system, such a small allocation at the beginning of the application might be actually just after the libc. So we'll see about that. Okay, then we get the flag. Oh, by the way, this will also put the flag in the buffer in libc. This is, we'll probably not do anything about it, but libc also has a buffer for a given file. Like if you open a file like that, it has a buffer, and if you read something, it gets read into the buffer as well. So you might find it in heap due to this like malloc and reading into the malloc, but you might also find it in libc memory, or a pointer in the libc memory to the buffer, where you can find it as well. So it's something to keep in mind. Like, you know, libc is also code, it also has side effects, and the side effects also cause that some things appear in memory in some places, so sometimes you can abuse it. Okay, and then we have print message 1, and we call print message 1 on input. It says now, and it calls print message 2. Okay, which says like it will be printed, blah blah blah. I don't know why they do this. Maybe they want to like protect some stack or whatever. Anyway, at the end of the day, they call print. So the problem is that this is put in the place where you expect the formatted string, you know, like something like oh, like ASDF is %x or whatever, right? And a new line. Now, we as attackers actually control this, and there are quite a lot of fun tags. Well, first of all, you can use %s to actually leak stuff from memory. Like, oh, by the way, another requisite, a really strong requisite here is that the stack, something on the stack, you control something on the stack, you control the arguments of printf, which you are going to be printing out. So we need to both control the format string here, right? Like this first argument, but we also need to control the stack. It doesn't have to be the stack immediately after printf, because glibc has nice features for hackers, so we are going to be using them, but it does have to be on the same stack somewhere after the print. It has to be after, it cannot be before. It would be great if it could be before, but there are actually some interesting caching mechanisms for arguments in printf, which make integer overflow impossible for a reason. Do just crash. Read the source code of printf if you're interested. And yeah, the source code is super long, by the way, but it's an interesting read. Yeah, so if we like would do this, and here we would place somewhere here, like for example here, I'm just guessing, right? We would place the address, like some address in memory, like if we would know the address of the flag in memory, then it would just print the flag. Obviously, we couldn't use just %s, because %s would take the first argument on the stack after this, which would be some probably like stack stuff in this function, which is totally not our argument and it's totally not controlled by us. Instead, what we could do is we can do something like this: a percentage and then number of the argument we want to print, which means basically the distance between the stack, this place in the stack, where the arguments of printf are expected, and whatever we control divided by 4. Why 4? Because the size of one element on the stack is 4. So let's say like 7, and then you do a $, and then you do like s, and that means print the seventh argument to printf, which by accident would be something we control on the stack. So this is where we'll be going. And another fun one is %n or %hn or percentage, which you cannot see because let's do it here. %n, %hn, and %hhn, which you can by the way also use with this notation. This is write an integer into memory, write a short into memory, and write a byte into memory. H is basically half, like so half of an integer, and this is like half, which makes it a byte. Like integer 4 bytes, half of a half is 1 byte. What kind of integer do we write into memory? We write the number of outputted characters so far, that printf has outputted so far. So if the printf is outputting, like if we've written like 4 bytes, then printf will actually and then if we let me make it more clear. If we do a and then %n and then some address, right? under this address, printf would write 4. Why 4? Because we printed 4 characters before %n was reached. %n just writes stuff to memory, it doesn't output anything. Yeah, and that's it. Now what we, does %ln or lln exist? It's a good question, I don't know. Disconnected writes that yes, so that's probably the case. Would it be useful? I don't think so. We actually usually use just a byte because of reasons. So, okay, now a fun fact. Here on the stack, this buff is on the stack, which means that we have on the stack the address where the flag is located. So the only thing we need to do is we need to find the right argument on the stack which contains the flag, and that's it, game over, we are done. And yeah, let's just do it. Like, we can do it by hand. There is absolutely no magic here. We just need to go to the proper directory, which, let's do it. And sorry, this is absolutely not what I wanted. Here, let's go to the proper directory. Let's take a look what's here. Yeah, vuln flag standard setup. So we are going to echo something. We are going to echo %x just to check if the format string works. And we are going to call vuln. And it says your input will be printed, and it says A, which means that in the memory there was a 10 after on the stack somewhere, right? So what I'm going to do is I'm basically going to just use S to print a string, and it will crash if I do it right now because 10 isn't a proper pointer in memory. Well, it is a proper pointer, just that memory under address 10 doesn't exist, so it crashes. And now I'm going to use this, like, this is by the way the same as like printing $1 because $1 would be like the first argument, so it's the same, so it just crashes. And now I'm going to change this 1 here to 2, 3, 4, 5, and so on. I could count it in IDA, but it's a waste of time. I can just brute force it, so I'm just going to brute force it to something less in memory, but yeah, like nothing interesting. 4, not the flag. 5, not the flag. 6, not the flag. 7, not the flag. 8, not the flag. But oh, by the way, is this? Yeah, this is our format. So yeah, we are still flag.txt. We are getting there. We are in the right neighborhood. No. 11, no. 12, no. 13, no. 14, no. 15, no. 16, also no. 17, that's R. It might be quite far off, actually. I'm not worried yet. I will be worried in, like, if we don't hit it around 25. 22. I skipped 21. Let's do 21. Okay, 23. 24. No, nothing. 25. Segmentation fault, that's fine. 26, nothing. I'm starting to get slowly worried, but I did miscalculate something. 29. 30, null. Okay, that's nice. It doesn't crash for 0 address, but it would crash for like 1 address. As soon as we get to the arguments of a program, then that means we failed. So we'll have to do something else. Yeah, here we are. We get the flag. 37, so we had to be more patient than I expected, but it was still faster than like trying to determine in IDA what is the distance on the stack between printf's arguments and where the buff is located, because what we hit here with 37 is actually this variable on the stack. So it has the address of the memory where the flag is located, and that's it. Like, this is the whole exploit to this challenge. You just had to, you know, understand what you're doing, and then you could do it. And get the flag, so another flag is solved. Yeah, the best surprise sort of rise that, hey, you could just do it with bash. Yes, I could, but I'm ashamed to admit I do not remember the syntax for the for loop in bash, and I always have to check it. So yeah, there we have it. Speaking of, I can actually show you. Oh, you see the question right there. Perfect. Speaking of format strings, have you ever seen %n used in a legitimate case? I think I used it once or twice in a legitimate case. But it's not like super needed because printf and glibc at least returns, like the return value of printf is the number of characters written anyway. So yeah, I think I've used it once or twice, but that's about it. So yeah. Is picoCTF one of the most popular CTFs, or why do so many people talk about it? I think it's the most popular entry-level CTF. Like, there are some entry-level CTFs, but picoCTF is the most popular entry-level CTF. Apart from that, it's actually being made by one of the best teams in the world, PPP. So, yeah. And they also keep the challenges running. They also, like, this is actually a competition while it's running, like for a week or something, for like high school students, I believe. So yeah, and it's a really good CTF as well, and it's kept online forever and ever, so people can always go there and train. I think another CTF like that would be, the Beginner's Quest from Google, which is also kept online and also targeted for beginners. But picoCTF. My apologies. So picoCTF just has more challenges, so you can play with it longer. Okay. What is the next level of a CTF after picoCTF? If you solve everything in picoCTF based on the challenges we are solving right now, just go after really like a real CTF. Like whatever CTF which is around like a normal CTF, like normal ranked CTF, 20 to 100 or like even 0 to 100 points, and just play it. If you solve these challenges here, which are for like 300, then and like even the ones which we are still to unlock, which are probably for like 500 and more points, you will be able to solve challenges on a real CTF. The way in which you Google small stuffs makes me overcome my imposter syndrome. Yeah, so this is quite funny, right? Because like, for example, after you'd expect somebody who is like, or yourself, right? After coding for like 10 years or 20 years, you'd expect to not have to look up anything at Google, which is absolutely misguided, and that's absolutely not true. That's not how it works. It works that you will be still Googling for stuff, even more. Like, I assure you will be Googling more than you were in the past, but you will be faster at it, you will know where to look for stuff, and you basically focus on getting in your head that stuff exists, and when you know that it exists, you probably know where to find it. And you know, you do not have to keep everything in your memory, you just Google for stuff. And yeah, and you cannot know everything. So like, for example, you told me the ICS today, I didn't know what's that, right? Or IC, because I know a different term for it. I knew SCADA. So like, and if you tell me something from like databases, I would probably be like, whoa, this is like, I had no idea, because I'm not a specialist in databases. So like, you cannot know everything, so there would be a lot of Googling anyway. And if you'd see me when I'm actually writing a project, I'm like, yeah, like most of the time I feel I'm like reading stuff on Google. And I'm not reading because I have no idea what I'm doing. I'm reading because I need to check the details anyway. So yeah, you might have seen my tweet about it, where I was like joking that when I was coding with like 1 or 2 years of experience, like 5 years of experience, I just like coded and that's it. And now I'm basically like, when I want to open a file, I do like, I check in man, I check somewhere else for like small details, and then decide to use a different function. That's basically how it goes. Like, you do not stop making errors, you just are faster at debugging. And we should go for another challenge. Where are you from? I sense a hint of Eastern Europe. If you sense only a hint of Eastern Europe, I am taking this as probably one of the greatest compliments I've ever heard about my English, so thank you. Yes, I am from Poland, which isn't Eastern Europe, it's Central Europe, by the way. But it's close. And it's like also a Slavic language. Polish is a Slavic language, so it's the same language group as Eastern Europe, basically. Cool. So, vault door 5 for 300 points. Let's do this. It's a reverse engineering, and then we have waves over lambda. What is this? We made a lot of substitutions to encrypt this, which doesn't matter because if you do multiple substitutions, still counts as one substitution, but whatever. Okay, then we have general skills. I want to be a rock star. Again, I think we solved something like this last time, but it's another song. Then we have binary exploitation, forensics. We have recovered the binary and images. Yes, let's do this. I really like images. Let's do images. So, investigative research. I mean, it doesn't really matter which order we do because we have to solve all the challenges anyway. So, there you have it. It's called mystery, the mystery images. Sorry, let's take a look, open the file really quickly. It's, you see this string, it means it's a Linux 64-bit binary and also an ELF file, so we know what we are dealing with. Now there are 3 images. This is image number 1, where'd the flag go, image number 2, also where'd the flag go, and image number 3, which is, surprise, surprise, also where'd the flag go. So, and the images are PNGs. So if we open let's open it here, we can see it's actually a PNG. Cool. So the question is, well, we can just try to, just randomly look at the images and stumble at stuff like this, or we can actually look at the code. I'm going to just look at the images randomly and stumble on stuff like this because it's faster. So let me open the notepad and I'm guessing. I'm going to guess that for each of a file, every third letter was written. So the first file contains letter number 0, letter number 3, 6, 9, and I'm guessing that the other file will contain letter number 1, number 4, number whatever is like 7, and so on. This is my guess. I'm not sure about this, but this is my guess. So I'm copying this. Then let me open the second file. Sorry, let me open it in a hex viewer. This is, by the way, Total Commander. And it doesn't have anything at the end, which gets me confused. How many bytes are here? This S is at the end, so I'm going to like write this S here. And then we had a third one. So let's also open this and go to the end. And we have this. How many... does this S? Yeah, because that's fine. I'm wondering about this because this has like, I'm wondering about this character here. Because as you can see, right, this is the IEND. So IEND is here, and then after IEND, this is, okay, PNG is encoded with chunks, and this is the length of a chunk, which is 0, and then there is the name of a chunk, which is 4 bytes, and a checksum of a chunk. So this is like the name, and then this is the checksum, basically, and so it's 6082. The checksum for the empty chunk and PNG will always be the same, which means that all the IEND chunks will have the same checksum, which is IE 426082. So if we look here again, we have, it ends here, so we still have this 85 byte here. I'm a little worried about this stuff. So that I might be wrong with it, with my prediction, it seems here, because there is this like 73 bytes at the end, which I don't really know. Okay. And what I'm missing, right, is like picoCTF. So we have a T here, we have a C here and an F here, we have a IC here. Where is my P? I do not have a P. CTF. But yeah, it's a little bit more weirder than I expected it. This might actually like be the P which I'm missing, and this might go somewhere in the middle, but I think we will have to... What I'm going to do is I'm going to still compare the image files side by side. Yeah, only at the end there's the difference, so... Yeah, and it also marked this thing. Can I somehow easily decide what I'm looking at here? No, I do not have a good idea. Yeah, which means we are going into reverse engineering the binary. Perfect, let's just open Tonight. Yes, I also downloaded the binary. So this is the binary. And let's see, I'm again going to go the compiler because why not? Okay, so it's, it's also really short. So we open the streams, let's just mark it like F, G, and H. Then we read it to some pointer, we read, where does it read? Oh, from the stream. So this is where it reads the flag. So it reads the flag here and the flag goes here. Then it outputs V16 into H. It outputs whatever char into G and the next char into H again. I'm not really sure what's the like. So, okay, so V3 is the beginning of the flag, so V3 plus 21. We know that the whatever we have at the beginning of the G file, which is the second file, is the 21st character of the flag. Now the problem is that that was that 85 thingy, not the S letter. But just in case, I'm going to assume this goes, like, they actually by accident added the 85 and never noticed it. So I'm just going to assume that this is supposed to go to the 21st position. So yeah, like 21st position S. What's V16 and V17? Let's look at it. So V16 and 17, where is it? Oh, it's, yeah, we don't know. Here, we have to look here. Okay. So put char 62. And no, I don't really understand where is it grabbing this value from. It's probably somewhere on the, yeah, where's the pointer? So no, this is like the, okay, so this is P, like the pointer points to P, this points to I, and this points to, okay, so this is fine, this is outputting like IC, so this is this stream, yeah. So this is IC, which is fine. It skipped the first letter, I think. Did it skip the first letter? Maybe it didn't, maybe we'll find it somewhere else. But maybe it did, but we can always guess it as like P, right? Whatever. Then it goes on to here, 20th. So 20th is the pico, sort of P-I-C-O, C-T, so that's the T which we get here. And then what else do we output into here? We output the characters between 10 and 15. So 10 and 15, we output them. So these characters are, yeah, 10 and 15. So what we could do is we could do like this. Let's make a lot of A's. We know we have picoCTF at the beginning and we have this. Then from the 10th character, right? So where is the 10th character? I'm looking at something you do not see on the screen. I'm looking at the column. So this is 9 characters. So wait, this is 10 characters, so it would be here O-T-H-A and underscore. And then we go to the 21st character. So this is 20 characters, this is this one, this should be S. Well, it's S or like, this is the weird one, right? So I'm not really sure about this S here. Then looking here, from the 6th to the 10th, we actually output them here. So here, where is here? Here is F, and F is this one. So this one is this one, right? Oh, I probably shouldn't have removed this. How do we get the other stuff in the F? We have one letter here, so that would be, I guess, this one, and what's V7? Why is it like incrementing V7? V7, oh, now I get it. And outputs it to G. So which character is it? It's the character number 18, so it's this one. PCO. It's pretty weird. Well, we know it's picoCTF anyway, so why do we bother? But that explains why it's 85, because we actually increased it several times. We increased it, what, 4 times? That doesn't make any sense. How many times do we increase it? V7 is 18, so it's that character, and then we increase it. Well, this is just 4, like a loop of 4, right? So we increase it 4 times. How do we get from a decent letter into 85? Like 85 minus 4 is still 81, and that's still not printable, so I don't really get what we're doing here. Maybe it will be clearer later on. Okay, anyway, yeah, 6 to, so 6, let's find 6. 6 to 10. So I believe like 6, so that's what we are copying there. We are copying the pointer plus I. So we are, yeah, copying to the stream, which is F, and F for now has only 1, so that's C. So yeah, so we get F, A, N, Anava, and something, right? And okay, now we are still missing the end, so we have until 15 to 50. Okay, this goes at the end of F, which means like this goes to the end, but it goes from 15, which means that doesn't make sense. Like this, we just, what happens to this? I don't know. I mean, this is just, it's again written here, so I do not understand that redundancy there. Alright, well, whatever, doesn't matter. From 15, right? So I'm just guessing this is 15, yeah, this is 15, so yeah. I don't know, let's try it. Yep, that's correct, so we're done. I could have spent more time like looking at the code and trying to figure out really like what is the reason of this, what is this, and what's happening here, but that doesn't matter. As long as we get the flag, that's fine. So that's about it. Like we had to actually read the code to figure out how the flag was like partitioned into the 2 images, and then we got it. I think one of the images wasn't really needed anyway. Let's see how many tasks. Oh, perfect. We solved 3 challenges or 4 challenges, right? And we have still more challenges to go through. Like we were at 23, now we are at 26. I do not understand how this works. Well, I do, but yeah. We have some more time, so another binary. I'm looking for something different, but we didn't do it today. A packet capture with a key. Is this going to be as guessing as the last one? I'm kinda afraid to look at it. Then we have forensic. This pasta is up to no good. Okay, let's do this one. It's a forensic, another forensic, but a different one. So it's called pasta. And I'm going to download it. I guess I can close this one. Okay, the file is called CTF and it looks like a pasta. Excellent. I'm not sure if it's al dente, but let's hope it is. I guess we will do malloc at the beginning of like next week's stream. Or maybe like if we do this one quickly, we can take a look at malloc as well. So this is a PNG file. What you can see here, I'm not sure if you can see it, I can see it, is the banding. The banding is pretty weird here, which means like something weird happened with this PNG. PNGs don't have weird banding like that. Let's open it as usual in a hex viewer, because why not? Is there anything here which is interesting? There are basically no headers, just the basic headers. Let's go at the end of the file. There is nothing interesting here, just the end. Oh, we do not see it. My apologies for that one. Here we go. Just the end, to the end chunk. So yeah, there we have it. Now, what you might want to do in a CTF is basically find the original image So basically grab this image, put it in Google search, and like see if you can find the original. That usually helps a lot. So images, google.com. There are two search engines which you need to care about. And the first one is imagesgoogle.com. You just drag and drop the file and it will look for it. And let's see, it's not the best one because it looks for stuff which is, it basically like tries to determine what is the image about, and then it tries to find similar images. Is something like, yeah, none of these are looking identical. Maybe this one is actually looking identical, right? Yeah, this one looks kind of identical. The best of Missouri, okay, like they get a free advertisement, I guess. Where is the image? Where is the image of pasta? No image of pasta. Is this like a bait and switch? Is this the pasta? No. This is not the pasta. Yeah, like they totally like, this totally is the image we are looking for, but whatever. Okay, so this is the first search engine I mentioned, right? And the other engine which you might look at is called TinEye reverse image search. And this one is more like, it doesn't have like as a huge database, but it does find exactly the same image. So okay, it seems to be some kind of a stock image, I guess. It's a JPEG, so like, yeah, just download it. Okay, I'm a little afraid of clicking save as. Okay, no, that doesn't work. Why doesn't like I want to go over and see the image. It seems to be a stock photo of some kind. Yeah, but we cannot actually open it. Oh well, if it's a JPEG, it's not that great anyway, because just the compression and like compressor and decompressor and encoder differences would make it not really interesting for us. Cool. So next step which you do is you actually grab this and okay, what is this? Wait, I see this. Do you see this? P. There's a P here. Yeah, like I'm going to like draw over it for you so you really see it. So okay, we already know this is an image Stegano. This is not a file format Stegano. How do we get the rest of the flag in that case? Okay, let's open it in GIMP. And let's do some image magic. You can you can see the reflections. Okay, that's fine. I thankfully didn't. Okay, here we go. You're saying that when the image is being loaded, you thought you saw some layers. Okay, so what you might have seen is the fade-in effect, disclosing the flag for a second. So what we are going to do in that case, we are going to start with the levels, I guess, with the curves. So let's go with curves. And oh, this is absolutely amazing. You do not see curves looking like the chart of the curves looking like this. I'm not talking about the line, obviously. I'm talking about these bar charts here. This image is really segmented, which is quite interesting. So let's try and look at each segment at a time. So what I'm going to do is I'm basically going to do it like this. The image will start looking weird, but do not worry about it. And yeah, so let's start with first one. Okay, no, this is not interesting. Basically what I'm doing, this is like the a chart of like the brightness, right? So this is like super dark here and this is super light here. And now what I'm going to do is I'm going to grab each of these lines and make a conversion chart that makes everything else dark, which means everything, I'm doing the line, right? I change the line to like a peak, like this, with everything else dark, and only this one part of the brightness pixels are going to be light, are going to be like super bright actually in this case. So yeah, but there is nothing interesting here, so we need to move it a little. Let me maybe move it somewhere here. I'm going to, I guess, do something like this at the beginning. No, but okay, let's look at this one. I need to... It's kind of annoying because I need to move all of them separately. Did any picoCTF thingy appear? No, nothing appeared. Can I just move it? No, I cannot. Let's do the next one. No, nothing fun. Next one. Nothing that looks like a flag. Next one. Nothing that looks like a flag either. I might be totally like looking at the red herring right now, by the way, and this is fine, right? Because we still need to check stuff. But I have some other ideas if this fails. That's fine. Like we can use up some time. So we see the P here, but this is not really what we are looking at. We want the P to be the P should be like full color for us. So if this is the way they encoded the flag, which I do not believe it is. I think I actually have an idea how they encoded the flag. The flag is probably encoded on one of the channels, one of the pixel layers. You can see the P clearly, right? But just the P, which again probably means we are looking at the wrong thing. Yeah. So let me just like, oops, that broke. Let me just look at the rest of it really quickly. But yeah, there seem to be no shapes showing up, so that's not it. Fariseo was right that he would try Stego solve for extracting layers. Nah. I'm wondering if I can do anything smart here which might help us, but I don't think so. Will my donation script work today? Let's see. If it doesn't, I'm going to just say that I got a donation from Sparky Parrot, who's saying, no spaghetti code on your stream, great streams. Oh, it works, perfect. Thank you for the donation, much appreciated. And yes, this is not spaghetti, this is a different kind of pasta. Cool, but we are looking here. I don't think we can cut it in channels as I would like to cut it. I do have a tool which cuts it into channels, but I'm wondering if I should use the tool, or rather if I should use just like write a tool. Yeah, let's just write the tool. So the idea I have is that, you know, when the color is basically encoded with, like you use 8 bits for encoding, right? And you can grab, for example, only the 0th bit of all the colors and display that, only the one, like the first bit, only the second bit, only the third bit, and each like of these, this is called a bit plane, by the way, and each of these bit planes, you can display them separately. So maybe there's something online like image to bit planes. Bit planes were more important historically than they are now, because historically, like, some graphic cards expected you to put each bit of a color in a different place in memory. Using MATLAB, no, I do not want MATLAB. The composition of image, this is on ResearchGate. Convert images to raw, and like we can do it manually. Okay, let's do it manually, like enough time wasted, let's just code something. I'm going to convert it, give me 1 second. Okay, this is fine. So I'm going to convert it to a raw file, so CTF, I'm going to write it as a raw file. Do I want planar? No, I don't care about planar and RGB, this is fine. Or do I want planar? Let's do it planar. Maybe planar makes sense. Cool. Planar means that only the first part of a file will be only the red color, then only the blue colors, and then only the red, green, blue, obviously. Instead of mixing them like RGB per pixel, RGB, 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 we get only reds, then only greens, and only blues. And this might be a little better for us. Now it looks like this, and we make a Python script. MATLAB is good. Yes, MATLAB is fun. I had a lot of MATLAB on my university, and I've written some really long scripts for it, so it was fun. But after my university, I never used it. Neither like MATLAB, neither like what was called like Octane, I think. Octave, I think. Okay, well, whatever. Okay, D is, you know the drill. Byte array. Open CTF raw as a binary file and read from it. Now for the how should we do it? Let's just make 8 arrays. I think it works like that. For I'm okay. In a print ID of, let's see if this works as I expect it to work. I hope it does. No, I actually need to open the Linux console for this one. Python 3 go py. What? I'm confused. Don't get to print anything. What did I do? That's probably not what I wanted. Do I have to do this? How do you create a... Oh, I'm confused. I thought that actually worked. Whatever, doesn't matter. A is like an array, and 4 in range of 8, just like append to that array. I want it to be an array. It should be actually, yeah, it should be like a byte array. Append byte array of the length of whatever data we read. Is it fine? It's fine. Okay. Now, for every byte in D, we do for every bit now. So for every bit of index I in range of 8, we do append. No, we actually need to do this. Enumerate. Okay, so we get the index position, we get position of the byte, we get the byte, and we now get the bit. So we extract the bit. The bit is byte moved by j. Doesn't matter which direction we move, like which side we go through, from the enter, from the top, and we extract it. Then we multiply it by 255. So we get a black and white image. And now we put this in A under the bit, under the index we put the bit. It's no longer a bit, but whatever, doesn't matter. Yeah, like for readability, let's do it like this, but again, doesn't really matter. Now, I in range of 8, what we want to do is we want to basically write it. So open, like plain, and the number of plain, raw, write binary, and let's do it like this as f, and f right the a of I. Okay, so we basically separated the bit planes, and now we can run it. It either is slow or I forgot some incrementation, but it's probably just slow. Why is it slow? It's 1 megabyte. It should already finish. Very slow. Did I do something bad? Now it's finished. Okay. Obviously, this is my favorite bug. I always make this mistake. Always, I forgot this when I'm doing like writing to multiple files. Like seriously, like it's quite funny. I should have learned to write on my own mistakes, but it seems I don't. Remember to close. Okay, I do not have to close because with is actually a construct which calls first when it calls open. It actually on the object returned by open it calls enter. And then when we leave this scope, we leave this block of code, it will call exit, like a exit method basically. And this method closes the file. So I do not, if I'm using with, I do not need to close because it will close automatically. Okay, and now we have like several plain files. Now what we need to figure out is we need to figure out what's the resolution of this image. And the resolution of this image is, if I could slightly make it, yeah, 8 to 6. So 8 to 6 multiplied by 3 is, I have no idea how much. I'm multiplying it because I actually wanted to show me all the colors next to each other. Like right on the right side I want to have on the left side I want to have reds, then in the middle greens, and so on. So multiply it by 3, and this is it. Now let's look at here. Then how much? Sorry, it was vertically 620. I needed 8-bit because I'm looking separately at it, and I think that's it. Okay, so it says picoCTF, and there is something slightly visible here, but not really. Don't show it. This is the first plane. Okay, so this is the bottom 2 planes. I have this one in the bottom 2 planes. Which is... Did I mess something up? I messed something up. I know what I messed up. I'm not going to get them next to each other. I'm going to get them one under the other. So I need to redo the size here. And I need to 620 by, yeah, this is fine now. And I actually, you know what, I'm just going to go with like 620, and I'm going to use the planar and 24-bit. Okay. And don't show this dialog. Okay, now it's readable, now we can read it. We can look at the other. So it looks like this. They removed the bottom 3 plane, like 3 bottom planes, like from bit 0, bit 1, and bit 2 are just removed, as you can see. And then what they did is they put the rest of the image there. So this is like the rest of the image. Like the planes from that image, right? Yeah, and this is the final composite of all the bit planes. So this is the top bit, which carries the most information. That's why we can give or take say that, hey, like we can recognize it. Then this gives some details to it, more details, and so on. And the least significant details have been removed. And this is very like a super standard way to do it. But usually you embed text, but they embedded an image. And yeah, this is the flag. Pico pasta 1s something. I don't know what's that actually. To know what that is, I should merge the planes. So to merge the planes, let's do... How do we merge the planes so that we can actually do it properly? So here we have the planes split, right? But we are not going to write them again. Instead of writing them, here I'm actually going to just grab the bit. And we are not going to go through all the planes, we are going only to go through the bottom 3 planes. And we are just going to use... we are going to put the bits at the top, I believe. Therefore, we put everything in the same plane, which is plane 0, and then we need to write it. Like plane, in the same bitmap, because this is like a bitmap now, so I'm just like, going to say it's output. And without this, and write just the 0th plane. And now I get a bit from that plane, and then I need to OR it with the bit which is moved by, I would say j, but j is not enough. So j, if j is 2, we need to move it by 2 plus 5. So plus 5, yeah. So we actually take the bottom planes and we move them on the top. And this is what we are doing here. Cool. And yeah, let's run it again. By the way, if this is confusing to you, that means that I am not explaining it properly, but that also means that you like play with images. Images are fun, and you get to like understand them a little bit more by heart, I believe. Okay, yeah, this is the like way better. Now we can actually see it, and we can easily read it. I didn't even know this is a $sign, so it's good that we did it like this. picoCTF pasta is life, written in a really weird way. So let me note it here. picoCTF pasta is life. Perfect. I think this should be fine. It should be the flag. I am quite confident this is the flag. And it really is the flag, so well done. We did a proper transformation on the image and we properly detected the flag hidden in a weird place by accidentally spotting a P letter. Okay, are there any questions? There are a couple of questions, so let's show them. Oh my. This is a really great remark. It's not the 21st character, it's the character plus 21. You are reading it correctly. I misread the code. Thank you for that remark. Yeah, that's really well spotted. But this is about the challenge where we do it, the reversing of the images, right? And I was wondering what the hell is wrong with 85, right? Like why is it OX85? And yeah, like this makes way more sense. Can I explain the general idea of this steganography challenge? So there is this really common method of steganography, which is called least significant bit, where you basically take the least significant bit of each color and replace it with data which you're trying to hide. And this challenge was identical, but they didn't grab only the least significant bit, they grabbed the 3 least significant bits and then replaced it with their own, not data, but their own image, their own bitmap. So there were basically 2 images there. There was the image on the top bits, like if you have, you know, let's just go here. If you have, like, let's write, you know, you usually write bits like this, right? Let's write them vertically. So this is like the most significant bit 7. Let's do it like from the top. 7, 6, 4, 5, 3, 2, 1, and then the 0th bit, which you cannot see. So let me retry it. 7, 6, yeah. So these are like 8 bits. This is the most significant bit. It's most significant because it tells you like it is responsible for the brightest color, for adding the 128 to the color, right? Everything else, if you sum up, it will give only 127, so this is the most significant bit, because if it's set, you add to the brightness of the color 128, in the scale of from 0 to 255, of course, right? So this is the most significant bit, and what they did, they actually like removed the details, the 3 bits responsible for the details in the image, which is why I said at the beginning when looking at the challenge, which I said like, hey, there is banding here, which is kind of weird. And this is why. This is what, if you remove the details, you get banding. And yeah, you mean you get like, you know, planes of color which looks identical, doesn't have any details, any grain in it. And so they removed it and they put their own image, like the picoCTF flag, in this part. Now the rest of the image was actually left as it was. They didn't change it, which means we still could, because these were the most significant bits, we still could say, hey, this is spaghetti. But there were no details in the spaghetti because they removed it and replaced it. So this was the general idea behind the challenge. And yeah, like nothing more to say there. And the banding, which I did mention, is like here, right? You can see the planes of the same color, which is, I'm not sure if you can actually, you probably can on YouTube, right? I hope you can. I'm not sure what the codec is actually doing with it. So there are no details here really. Like here you can see a lot of banding as well. If you're wondering what is this banding I'm talking about, let's just look for it at Google. Yeah, my wife really likes photography, so I've learned quite a lot from like, you know, like terms like grain or like banding or whatever. These are like commonly used in photography. So, or like actually like digital photography. No, photography, banding. Did it actually just disclose my location, or my home is? Let's see. Kinda. No, not really. Yeah. Well, you know, I live in like the Zurich area anyway, and if you watched all the streams, you know which village exactly. So, yeah, there we have it. But this is a Polish Wikipedia, but it's actually fine. Yeah. So this is like a gradient, a nice gradient, and this is banding, a gradient which is has a lot of, instead of like smooth color transitions, it has like visible color transitions. That's basically it. Cool. Okay, I think we are going to... Oh, there's another question. While converting from PNG to RAW, do we lose any information if compression is present? We do not lose any information because PNG is a lossless format, but this is true only, like, when using Irfan View, this is true only if the PNG is an 8-bit per color PNG, so 24 bits or 32 bits per pixel. If it would be like 12 bits or 16-bit per color, so it would be like 48 bits per pixel, then Irfan View would actually cut it short to 8 bits. I'm pretty sure Irfan View doesn't support like HDR images, proper HDR images. Or like proper high, like really high color resolution images. I thought we could only use BMP. So BMP, PNG, and RAW images are basically lossless, and you can use them. Some kinds of TIFF are also lossless, but not all of them. TIFF is a really large format, and you can actually have a TIFF using JPEG compression, because why not? So yeah, you are right with BMP. BMP is lossless, also PNG, also RAW, as I said. And by RAW, I do mean raw image data. I do not mean the photography RAW formats, because if you talk to a photographer, they will tell you that, oh, I do raw images and with my camera, not JPEGs. And that means something else. Raw images and camera and photography actually means like that they do it with a manufacturer's format, which is supposed to be as lossless as possible. And so that's and there are like, I don't know, like I'm going to say 50 different raw camera image formats, and I'm probably not wrong. We can actually probably check. There's a project which is called DC Raw. DC Raw supported formats. Maybe it's here. No, let's go with front ends. Can I just... Official website, that sounds good. Yeah, this is the project. Now, if they could just tell me what... Okay, formats. Yeah, I don't see a full list here, but it really supports a lot of formats. So yeah, you basically work with this, and yeah, like it's actually a really interesting topic, because like the actual raw image is black and white, well, grayscale, actually really high resolution grayscale, and then the color is added in post-processing due to like what's it called? Oh my, there was a like a... I forgot the name. There's a... Was it the Bezier's mosaic or whatever? Like there's a mosaic on the sensor and whatever, and the color is added in post-processing. Looks very... Let's not talk about it today, because I think there's another question. When are you and Live Overflow doing a crossover stream? We already did one. Quite like live overflow was streaming, and by accident we started chatting, like people in the chat were chatting like, hey, you should play Apex with Gunveil, and we went and played Apex with live on the stream, which we didn't do too well. Maybe we should redo it. We are both like Diamond League and Apex now, so maybe we should play. Okay, I think that's it for today. Are there any other questions? Which part of Windows do you think has the most vulnerabilities, the oldest parts of Windows? Like, if there is a part of Windows which was written years ago, then the probability of vulnerabilities being there is much higher. I'm not pointing to any specific places though. Okay, so that's it I think for today. How come the oldest part? Because the way you write the code changed and the tools changed. We have better tools which detect more vulnerabilities and like show more warnings, basically when you compile stuff. We have fuzzers in the development process. Microsoft has this SDL, which is like secure development lifecycle for the code, which they implemented, I don't know, like 10 years ago, 15 years ago. So if you look at code which was written like 25 years ago, they didn't have these practices, they didn't have these tools. So yeah, that's why old code. I'm sorry, I'm getting tired. So wouldn't it be the most audited? Yeah, there is this like myth, right? That, oh, like open source software is better because people can look at the code and find vulnerabilities. Yes, which is both true and not true. It's true as long as there are people actually looking at the code. And it's true for all the code. Like, there is a lot of code in Windows, there is a lot of open source code, and there are not enough people looking at it. So there will be code which has not been audited enough. And yeah. Are PNGs always written in 8-bit? By default, yes, but I think the format itself supports like higher resolutions than 8 bits. And again, that's 8-bit per color, so 24 bits per pixel, plus alpha channel if you add it, right? But I'm pretty sure PNGs support like 16-bit per pixel, sorry, per color as well. But I don't think I ever saw a PNG like that. Perfect. Thank you to my moderator, Disconnected, for helping me with the stream today. Thank you everyone for being on the stream. We had like, I think 130 people at one point, so that's pretty amazing. And thank you, Marble, for the donation, like just in time. Marble says, thanks for the stream, so thank you for the donation. And see you, oh, one more question. Would I say file systems and browsers are more bug farms in OSs? What? I guess I'm interpreting the question as like, would I say that file systems have a lot of bugs and browsers have a lot of bugs? Yes, but there might be different parts which are not yet well explored, which also might have a lot of bugs. Thank you for the donation. The donation says thanks, and I'm going to butcher your name now. Mugundhan Balaji Patabi. I'm sorry. I am terrible with international names. I need to learn, I know, but yeah. Thank you for the donation still, and I thank you for enjoying the stream. And see you folks next time when we'll be continuing picoCTF. We should solve some more challenges, so we should be getting closer to the end, even though the end is running away from us. I'm going to leave you with some music and see you next week. Happy hacking, have fun, bye.